Alright, this video is going to show you how to take the HEC1 model that you built in labs 7 through 9 and add reservoir routing at the outlets. I'm going to assume you already have a working HEC1 model that you would have produced at the end of lab 9. And if I open the hydrologic modeling wizard, we can recap. You should have delineated a watershed, initialized an HEC1 model. You should have created a soil type coverage, and I can see I've got a soil type coverage on the left. You should have a land use coverage as well, either a grid or a coverage, depending on which data you're using. You should have a curve number going through this GIS attributes menu, and you should have put in some precipitation data. If I come to my HEC1 model parameters, I need to select my watershed first. You should have a SCS type 2 24-hour storm. I have 4 inches. You're going to have some value that's a little over 4 inches for the 24-hour 100-year storm depth. That's the value you got from NOAA Atlas 14. I'm going to press OK. You should have a curve number loss method. You should have a number about 75. For a unit hydrograph method, you should have a Clark unit hydrograph. You should have about an hour time of concentration and a Clark's R of about 1.6. And no snowmelt data. And your hydrograph that comes out of this should look something like what I'm showing in this graph. Your peak flow should be in the neighborhood of 900 CFS and have roughly this shape. All right, we're now ready to add the reservoir. Step 1, we're going to select our outlet, and we need to calculate a storage capacity curve. So with the outlet selected, we go to calculators, detention basins, and define. And we need to put in 2 values. This first value by use DEM is the elevation of the outlets. This is the bottom of the reservoir. And what's called base elevation over here is what the elevation, the maximum elevation that you want to calculate storage capacity curve values for. You should pick something that's about 200 feet. So I'm going to pick 5,300 for my base elevation. And you need to keep the number of data points at 20. This is the first place you can make a mistake. You might get lucky and HEC1 will run if you make this number bigger than 20, but you will eventually run into errors if you make this number large. It should be exactly 20. Press OK. It'll show you a table of the values that it computes. These elevations are, if you're at the outlets, what is the elevation you're standing at, and then as you go straight up above you, if you were to build a reservoir that goes up to that elevation, what volume, what storage of water would that reservoir be able to hold behind it? Those values are in acre feet. You can press OK and it will create a plot for you. Next most common place to make a mistake is you need to press map the hydrologic model. It's not enough to just calculate this curve. You need to press map the hydrologic model, give it a name, elevation, and volume. You don't need to provide a name for discharge, but at least volume and elevation need one, and press OK. And then press OK again. Now we can go back to our HEC1 model parameters, and under routing data, we're going to use storage routing, and you can press define. We can check that our storage capacity curve was properly copied over to our model by using plot SVSE. This is storage volume, storage elevation. This plot should be exactly the same as the storage capacity curve that you created using the detention basin calculator. All right, next most common place to make a mistake. You need to uncheck SQ and SE and then switch from known outflow to compute Weir spillway. I'll show you later what happens if you don't. But these SQ is storage Q discharge and SE storage elevation. This is the same storage elevation as over here. This allows you to control how much water should be leaving the reservoir as the volume or the elevation of the water held behind the reservoir hits certain thresholds. That's useful for some cases, but not for the kind of reservoir that we're designing. We don't want those to be included at all. If you leave them checked, then the series of zeros of discharge values and the elevations will still get written into the HEC1 model, and so it will ignore anything that we put in for the reservoir characteristics and say no matter what's the outflow or what the elevation is behind the reservoir, the outflow will always be some fixed value. Probably 0, but it could be like Q peak or whatever value gets copied into that. What we do want to use are SL, storage lower outlet, SS, storage spillway, and ST, storage top of the reservoir. We want the lower outlet and spillway. You do not need to do anything for the top of the reservoir. And we need to do a couple things. First, provide an elevation. This is an absolute elevation, not relative to the elevation of the outlet. Mine was at 5,100. So I'm going to pick something just a couple feet above that. Let's say 5,105. As I increase the elevation here, I increase how much dead storage is behind my reservoir. That's the storage that can't ever leave. It just pools up. And I also need to change how big the lower outlet is. This is an area in feet squared, and HEC1 assumes that it's a circle. So you're going to want to think of areas that correspond to a diameter. You can build yourself a little table, use pi r squared. I'm going to start with, let's say, 10 square feet. Then you need a coefficients. These two bottom entries are coefficients used in Weir equations and orifice equations, and so the value is 0.6, and this other one should be 0.5. Do not change either of these two. You only need to control the location or elevation of the lower outlets and the area of the outlets, the size. Similarly for the spillway, you need an elevation here. I'm going to choose an elevation that's, let's say, 60 feet up, so I'll do 5160. And I need to know the width. This is a rectangular channel, so you're choosing a width which controls how much flow gets in using the Manning's equation or the Weir equation, whatever is the case depending on the elevations leading up to the spillway. So I'm going to choose a width of, let's say, 15 feet. These also need exponents and coefficients. This one should be 3.5, and you can leave the 1.5 that fills in by defaults. And then you're done entering the information about your reservoir. You can press OK, and then press OK again. Now you're going to want to confirm that SQ and SE were not put into your HEC1 cards. You can tell by skimming through here. If I see SV and SE values, that's storage volume, storage elevation. If there's another set of values that say SQ and SE, then you're going to get a fixed output, and we'll talk about how to fix that later. I'm going to press done, and I'm now ready to run a simulation. And this will be my first attempt. I'll call this Reservoir 1. Reservoir 1. And press OK. And I see that it finished normally, so I can press close. And now let's look at the hydrographs. This is the one that I started with, the peak of about 870. And what came out of the reservoir that I just designed has a peak of 450. You're going to want to look at your graph that comes out and see if you can pick out where the flow starts to use the lower outlet and when it starts to use the spillway. I can see that the flow increases as the head on my lower outlet increases, therefore the more head is on the orifice. and the amount of flow increases, then suddenly there's this dramatic jump in flow. This is when my reservoir has backed up enough water that it has started to reach the elevation of the spillway. So instead of continuing to increase head on my orifice, the lower outlets, more volume of water can use the spillway. This decreases my peak flow a little bit. If I let the water continue to back up, then the head would continue to increase on the orifice and the flow would increase more. So this is a pretty good simulation as it is, but I'm going to press cancel or close, and we're going to go try to change my simulation. Go back to edit parameters. If it's all blanked out like this, you need to use the select outlet tool, click on the outlet again, go back to my routing data and define. Now let's say I want to let more water through my orifice at the bottom, the lower level outlet. If I want that to happen, I can either decrease my elevation so that less water has to back up before water can start flowing out, or I can increase the size. So let's change this to 20 square feet, and I'll leave my spillway as is and press OK. Press OK again. And here again, I'm going to check that SQ and SE were not written to the card so I don't get funny output values. Press done. And this time I'm going to run the simulation again. I'll call this one Reservoir 2. Okay. It finishes properly. I can press close. And I'll go look at that hydrograph. So Reservoir 1 was the first one I did. And the difference between Reservoir 1 and Reservoir 2 is I increased the size of the lower level outlet. This produces the black line. My flow gets higher, but it doesn't last as long. The duration of this largest flow event through the bottom orifice is shorter in time. It's narrower on the x-axis. So your job is to fiddle around with the size of the orifice, the lower level outlets, that is, and the spillway, and also change their elevations to come up with some output hydrograph that you think is the best design choice for this location in Dry Canyon. There's not necessarily a right answer. In practice, you're going to have constraints about maximum discharges or minimum discharges to protect the aquatic organisms that live in the river, or perhaps you're going to try and maximize the amount of head that's on the orifice if you're trying to generate hydroelectric power on it. We're not providing you a specific use case, so you're at liberty to choose a design and therefore a reservoir design and therefore output hydrograph that you think is best for this scenario. So I'm going to close this out. Let's talk about some of the common mistakes you can make. I'm going to select my outlet, routing data, define. So if you did not uncheck SQ and SE, I'm going to leave these checked, and if I look at them, SQ is all zeros. And SE, these are the same elevations that I computed with the detention basin calculator. So if I leave these checked, but I still choose Compute Weir Spillway and press OK, when I come back to my HEC1 cards, I can see there's an SQ series of values and SE values that go along with it. You don't want this. When I run this model, even though I have all of the SQ simulation, even though I have all the characteristics of my reservoir input properly, because SQ was still checked, when I run this and look at the hydrograph that results, there's this third line that you can't quite see, but it starts on the bottom and it's zeros. Nothing happens. You don't want that. The way to fix it is to go back into your HEC1 parameters. I've got to select the outlet first. Go to define, uncheck these, and press compute weir spillway. And when I go back here, I see SQ is gone. If SQ is not gone after you uncheck those, that does happen sometimes, there's another option. You can select your outlets and go to tree, add reservoir, and my dot changes to blue, so it's now a reservoir outlet instead of the standard outlet. And this opens up another menu for reservoir data. It's exactly the same menu that you got to through the routing data interface. However, if you create a reservoir and then remove the reservoir, then that's often enough to hard reboot WMS to prevent it from writing those values out. So give that a try. So if you get any other kind of error when you try and run your HEC1 model, and it doesn't tell you a specific place to start looking, the way that you can try to debug this is go to File Explorer, and then go find wherever you saved your project files. Here's my Lab 11 files. And every single time you run an HEC1 solution or HEC1 model, it creates this SOL solution file and this out file, .out file. These are both text files. Open these up in Notepad or whatever program you would like. I'll zoom out a little bit. And when you get to the very bottom, if it finished properly, it'll say normal end of HEC1. If it failed, instead of saying normal end of HEC1, it'll tell you some error message. For example, I have one from a previous run that I prepared. When I go to the bottom, this one said insufficient data for storage routing. So you're going to ask yourself, what is the error that it's trying to tell me about? Go back to your HEC1 parameters, and if it says there is a problem with your routing data, well, go over to routing data and check all of these inputs. First check, is my storage capacity curve here? If it's not, go back to the detention basin calculator and do map to hydrologic model. Did you not uncheck SQ or SE? Did you give an elevation that is below the outlet level or above or too high so water never gets out? Check that all of these values look realistic and try running it again. If you get a different value or a different error, it'll sometimes tell you the name of a card to look at, like SV, in which case you know, oh, I need to look at the storage volumes. Maybe there is something wrong with that. But the idea here is go to your .out files and look to see what error message it tells you, and that should give you a place to start looking. The last tip is you're going to go through a lot of different simulations here while you're looking for one that's optimized the way you want it to be. And so they're all going to accumulate on this graph. You're not always going to want to look at all of them. So if you go to hydrographs, you have this one selected. You can choose delete previous or delete all. Be warned that if you do delete all, you're going to lose also your base case, which you might want to keep for reference. If you do that, you can go to read solution and find the .solution file, .sol, and press OK. And after doing that, it will restore whatever hydrographs were produced by the simulation file that you read. All right, those are my tips for you in doing this lab. Remember to follow along exactly the kind of steps that I showed you here. Check for the common errors that I pointed out. If you've correctly debugged all of those and you're still getting errors, look in your HEC1 out file and see if it can tell you where to start looking and debug from there. I'd be happy to help you if you can't figure it out on your own after a little while, but part of the learning process is just becoming comfortable with the way that these old modeling softwares give you results. So don't shy away from spending a little bit of time on debugging this. You will eventually get a feel for the way these work and develop the skills to debug it.